All right, I'm back. I'm on page 231, and I think we're going to do the entire page in this set of notes. What? I think I'm going to do, not at this rate, we're not. I think we're going to do the entire page in this video. All right, let's see if we can do it. So, first question is actually a review. So, if you just want to like do it and ignore me or fast forward me, like go for it. Find parametric equations for the line passing through the point. To do that, I need a vector, and to get a vector, I'm going to do, I don't know, the one with bigger numbers minus, oh no, it's directly even. This is how these end up so long. All right, so 14 minus -3 is 17. That's a garbage number because of what I know that we're gonna have to do in the future, but okay, 5 minus 5, 0. -3 minus 7, -10. That's my vector. So then my line is gonna be x, y, z. Well, whatever. -3 plus 17t, and then 5 plus 0t. Suspicious. 5 plus 0t. Y doesn't change. Y is always 5. So what could that mean? And then 7 minus 10t. All right. So that's what we have. Where does a line in the previous problem intersect each of the coordinate planes, not coordinate axes, the coordinate planes? So let's think about this. So I have my equation, trying really hard to keep that so that I can see it. Okay, so I have my equation, and I want to know where it hits, let's say, the xy plane. It's like I spend so much time just getting that right, and then as soon as I touch it, it moves. The xy plane, right? The z equals 0. Well, if z equals 0 and z is equal to 7 minus 10t, then 7 minus 10t equals 0, which means t is 7/10. And if t is 7/10, then I can find x and y, right? So if t is 7/10, that means that x is going to be -3 plus, oh good, 17 times 7/10. Oh boy, 70 and 49 is 119. And then minus 30 is what? 89? Yeah, so I'm going to say that's 89/10. Should I check that? I don't know. It's 70 and 49 is definitely 119. And I'm going to subtract 30. So yeah, I feel good about that. And then y is 5 plus 0t. It doesn't matter what t is. So y is equal to 5. And z is equal to 0. So I know it's 89/10, 5, and 0. That's where we intersect the xy plane. And I probably should have done that a little bit over. So maybe I'll use like the magic of this to do that. All right, so now let's do the YZ plane, right? So the YZ plane is what equation? What is the equation of the YZ plane? There's no x in there, which means x is equal to 0. So x is equal to 0. If x is equal to 0, then that means because of our line, -3 plus 17t is equal to 0. Which means that t is equal to 3/17. Ugh. All right, so fortunately, I already know that x is equal to 0. That's not so fortunate because I would have multiplied by 17, knocked out the denominator, gotten 0, but whatever. Y is always equal to 5, so I don't have to do anything with that. And then z, so this means that z is going to be 7 minus 10 times 3/17. Okay, so this is kind of interesting because I get, with the common denominator, I get 119 minus 30, which is 89, over 17. So think about that. What is this weird symmetry that's happening? I don't have an answer for you. Like, think about it. Get back to me. Right? So the symmetry that I'm referring to is for x, we got 89 over 10, 5, 0. For x, for the xy plane, we got 89 over 10, 5, 0. For the yz plane, we got 0, 5, 89 over 17. It's kind of interesting to me. And then think about this. Okay, so what about the xz plane? Okay, so what is the equation of the xz plane? So y is missing, so it's y equals 0. I always fall back to that, right? Like, I'm 100% confident on the xy plane being z equals 0. So in my mind, when I'm saying xz plane, y is missing, y is 0, what I'm really doing is comparing it to my thought process that the xy plane is when z is equal to 0. So that's why I say it out loud all the time. All right, so I would need y to equal 0. But when we look at our equation, y is equal to 5 plus 0t. Y is equal to 5. So y never equals 0 because y equals 5. Therefore, no intersection. I regret this. Let's go back to no int, period. All right, so how can we think about that? Well, if the floor is the xz plane, then that would be y equals 0. And the ceiling could be y equals 5 because it's a plane that's parallel. So the line that we found is completely contained on the ceiling. It's never going to intersect the floor. That's like a concrete way of thinking about it. All right. So what I'm going to do now is I'm going to talk about things that can happen in 3 dimensions. In 2 dimensions, there's not a lot that can go on, right? If you have 2 lines in 2 dimensions, you can have parallel lines that never intersect. Oh my God. That says never intersect. That says never. Good luck with that. Or they intersect. Those are your only options in the plane. In 3 dimensions, it's a little weirder, right? Because think about what we just talked about with the floor and the ceiling. Draw a line on the floor, draw a random line on the ceiling. They're not going to intersect, but it doesn't mean that they're parallel. So when that's the case, we call those lines skew. So you can still have lines intersect. You can still have lines be parallel, but you can also just have like weird scenarios where they're like shooting off at all angles. The odds that 2 lines are going to hit each other in space are very slim. Like, you just don't, it doesn't happen very often. So like, are the problems contrived? Not really, because it does happen, just not randomly, right? Like if you are imposing order on the system, things will intersect, but not like in general. All right, so we got this figure, rectangular coordinates, rectangular prism. It's a really common way of thinking about things. List some intersecting lines. Let's do something interesting, right? Like any 2 pair of lines that share a letter are going to intersect, like FD and DG, GC and CE, whatever, boring. Let's name some that you can't see. So for example, I'm going to put them like in sets, I guess. So these intersect. I'm going to say that DH, right? So that's like the top of the box, and I've gone like diagonal. DH will definitely intersect FG. What's another good one? So I could now do all of like the diagonals of the sides, and they're going to intersect, or the faces, I guess I should say. What about, I'm going to go from D to E. It's like a diagonal through the box, D to E, and A to H. Those are going to intersect. So what you want to do is try to think inside the box, I guess, in this case, where things that aren't shown, like you always want to be thinking like, what about this? What about that? Like try to find things that aren't shown where it works for intersections. That's not really going to work for parallel lines. Oh no, it will. What am I even talking about? All right, parallel lines, FB and HE, we can see it, it's true. CE and DF, we can see it, it's true, that's fine. Let's be more interesting. let's go. I'm going to use DC. So DC is parallel. Well, parallel has a symbol, so I could have done that, but I didn't. So deal with it. So DC, and I've thought about this for a while. You probably have an answer. Write it down. See if you agree. I think that DC is parallel to FE. They're like corresponding diagonals of this box, I guess you might say. So maybe BC. So if I say BC, just say it right now, say it right to your computer. I'm going to say FG goes parallel to that. Okay, so that's probably enough of that. Skew lines. Skew lines are lines that are not parallel, but don't intersect. So a definition of parallel lines is that the distance between them is a constant. Skew lines, they don't have a constant distance between them, right? So the distance between them varies depending on where you are. What does it even mean where you are? So for example, let's do an easy one. Easy-ish. FB should be BF, but FB, Facebook, who knows? And HG. Holy cow, what is that? G is probably my least favorite of the letters. Although when I make my YouTube videos, I mean, this is on YouTube, but when I make my other videos, I get really anxious when I have to make a K because I can't decide where to connect things. But as you can see, my G's are atrocious. All right, so let me do one more. So I'm going to do AE, and then it's kind of you can basically randomly guess, and you'll probably come up with one. AE and HC. Nice, easy letters. So these are skew. So you got intersecting, you have parallel, and you have skew. So we want to be able to figure out when these things happen. So I'm just going to go through the notes here. What can happen is if the lines are parallel, then their direction vectors will be parallel to each other, which means their direction vectors are scalar multiples of each other. If that doesn't happen, then we have to figure out, are they skew or are they intersecting? And what we basically do is we reduce it down to a two-dimensional situation. We ignore one of the variables. Usually you just ignore Z, and you do the thing that we did when we did parametrics, right? So we create a dummy variable, we solve the system, think literally back to what we did when we solved this for 2 dimensions. And then we solve that. Then we take those values and plug it into the variable that we ignored. All of this is talking, and I should just be doing the problems. But anyway, once you plug it back in, if you get the same number for both of your Z components, then the lines intersect. If you get different numbers, then they are skew. And that's how you do it. So I'm going to do a bunch of problems. So don't worry about, if that didn't make total sense, you could go back and listen to it later. And it probably still won't because I didn't do a great job explaining it. But let's try this. So find the intersection of the lines if it exists. Otherwise explain if they are parallel or skew. So first step is find the direction vector. So you can just read them off, right? So I'm going to say that V1, the vector for this line, is 4, 8, negative 12. And I'm going to say V2, the direction vector for this line, is negative 1, negative 2, and 3. Okay, so look at them, corresponding components. If I do, I'm going to go 4 divided by negative 1 is negative 4. 8 divided by negative 2 is negative 4. Negative 12 divided by 3 is negative 4. So I divided corresponding components, and I got negative 4 every time. So it turns out that V1 is actually just negative 4 times V2, right? And you can confirm that by just multiplying it through. Therefore, so the direction vectors are parallel. The lines are parallel. And that's great. That is the one that you want to happen because it means that you don't have to go through the process of solving the system. But I'm going to come back in another video and do the next page of notes in which we basically solve a lot of systems. So I will be back, and I will see you then.